Eric Burgess here. The largest group of moviegoers by age is the 40 to 59-year-old age group. This group constitutes 27% of the moviegoing population. A theater randomly surveyed the customers over a 3-week period and found that out of the 411 surveyed, 158 were 40 to 59 years of age. At the 0.01 level of significance, can it be concluded that this differs from the stated proportion? And then we've been given some lovely steps that we can follow along with the problem. And just so you know, we will be using only the calculator. We will not be using the chart or the formula method for this problem if that is the method that you're used to using. So let's go ahead and jump right into it. So step 1, state the null and alternative hypothesis. Identify the claim. So our null hypothesis is we're dealing with proportions here, and we're dealing with the fact that they think a proportion is a specific amount. So we're going to have an H naught and an alternative to it, something that's different. And the first one is always got that equal sign there. So we have a proportion is equal to something, and a proportion is, and we don't know what the second sign is without looking at the problem. So it says here the group constitutes 27%. And so that right there is our first proportion. And they're saying that this is the proportion. This is what it is, guys. It's 27%. And so we would say the proportion is equal to 0.27. But then we want to know if it can be concluded right here. Can it be concluded that it's different from the stated proportion? That it's just not 27%. Can we conclude that? So that's going to be the second one. So we're going to say that it's not 27%. It's not 0.27. All right. And now we need to determine the claim. So the claim is the one that we want to be able to say something about. And right here it says, can it be concluded? So those are buzzwords for what we want to be able to say. And we want to be able to say if it's different than the stated proportion. So that's going to be the second one, that it's not the same. So this one is our claim. All right. Step number 2, identify the tails. We can identify the tails simply by looking at the alternative hypothesis and the symbol that's used. Here it's a not equals to sign. And not equals to means that there can be an error below or above the stated null, this guy. And that means that it's a two-tail test. Two-tail. It's because of the not equals to. That's what it tells us. Next up, identify the distribution. Well, we're dealing with proportions here, and when we deal with proportions of populations, we use z-scores. So we're going to be using a z-distribution. Step number 4, use a calculator to find the test stat and p-value. All right, so for the calculator, it's going to want a couple of things. Let's go ahead and get the numbers out of the problem. So first up, we've got the largest group of moviegoers, 40-59. So we've got that p is equal to 0.27. 0.27. And then we're going to have a p hat. This is our point estimate. And they found, if we look at this, out of 411, 158 were in the age group that we're looking at. So that means that these two numbers, their ratio is our p hat. So it's going to be 158 over 411. That's going to be our p hat. And q hat is just going to be equal to 1 minus p hat. So it's 1 minus 158 over 411. So we've got q hat now. We've got an alpha of 0.01. We won't actually need this for this part, but let's take note of it. And that's it. That's all we've got here. So let's go ahead and go to the calculator, turn it on. All right, so we're going to go to stat tests, and then we're going to go to the one proportion z-test, because that's what we have. We want to do a z-test with proportions. So number 5. So first up, p naught. Well, we have p naught right here. It's this guy. It's 0.27. 0.27 is the p naught. The x is the 158 people that fulfilled the category that we wanted, 40 to 59-year-old. So they fulfilled that criteria. So there's 158 of them. And then the n is 411. That's the total number of people that we surveyed. 411. Now, I just realized this. We actually didn't need to write down p hat and q hat like this. If you're going to use the calculator, you really only need to identify x and n. And the p-hat formula is just x over n. So you could just use this instead if you're going to be using the calculator. Up next, our alternative is not equals to, so that's already set up for us. And I'm going to go to draw because it gives us the test stat and the p-value without any other stuff, and even does a little bit of drawing for us. So here we've got our test stat. So our test stat z is equal to 5, and I'm going to round to 2 decimal places, 5.23. And our p-value, p, is so dang small it's equal to 0. So it isn't actually 0. If I actually go in and do the same thing, but this time we use calculate, we're going to get an atrociously small number. See, this is the p-value is 1.74, but it's e to the minus 7. So if we were to write it out, it'd be 6 zeros, 1, 2, 3, 4, 5, 6, and then 174, on and on and on. It would be a very, very, very small number, basically 0. And a z-score of 5 is like off the charts high. So these are red flags here, big time. So, okay, next up, step 5, it wants us to sketch in shade. So what we're going to do is we're going to just go ahead and sketch this out. And we're going to go like this. And in the middle is 0. And we need to find the critical values so that we can properly graph that. So the critical value is defined by alpha. Our alpha is 0.01, and we're dealing with a z distribution. So the way we find a z-score that corresponds to 0.01, right? Because there's some down here and some down here because it's a two-tail test, like we discussed earlier. So that means 0.01 over 2 is in here, and 0.01 over 2 is right here. So we're going to have 2 critical values. They're going to be the z-scores that go with these 2 spots, where if it goes beyond this, it's too far. So that's just going to be 0.01 divided by 2. That gives us 0.005. So what we need to do is take an inverse of this. So if we go to distribution menu, we hit blue and then distribution, and then go to inverse normal, number 3. We give it our area. Now we just found it was 0.005. And since we're doing a z-score distribution, that's going to be a mean of 0 and a standard deviation of 1 because it's standard normal. That's always the case for z-scores. We hit paste, enter, and we get our critical value. So we take the plus and minus because the distribution is symmetric. 2.58 if we round, and then plus 2.58. So all right, we found our critical value. Now let's go ahead and graph our test stat. Our test stat is 5.23, so that's like way out here. Shoot, it'd be even further out here. It'd be like way down here. It'd be getting very small at this point if we were to draw this better. But there 5.23 is where our test stat is. So we are very far away from the safe area. We are in the shaded region, and that means that we don't think that the null hypothesis is correct. We have produced a lot of evidence to state that that is probably not right. All right, so step number 6, identify the test stat and critical value. So the test stat we already found in the third step, step 4, and we found that to be 5.23. And the critical value we found in step 5, and we found that to be plus or minus 2.58. Don't forget, you had 2 of them because we were above or below the mean. Now, decide about the null hypothesis. So, okay, step 7. In order to do this, all we do is we look at our shaded region and we say, well, it landed in the shaded region. Therefore, we reject the null hypothesis. Another way you could say this is that the p-value, that alpha is greater than the p-value. Meaning if p was big enough, we would be outside of the alpha region. But if it's not big enough, then we're inside it. Now our alpha was 0.01, but our p-value was 0. And that's why we also reject the null hypothesis, is our p-value is just way, way, way too small. Now step 8, conclude for the claim. Okay, so for step 8, to conclude the claim, well, we rejected the null hypothesis. So we rejected this guy. This guy, we didn't think he was right. That means that we have evidence here that says we think this one is right, that H1 is right. So we would say there is evidence to support the claim, and then we need to state what our claim is. So our claim was that can it be concluded that this differs from the stated proportion, that the proportion of moviegoers, right, because that's what we had, moviegoers, in the age group of 40 to 59 year old 40 to 59 year old of the population. I probably could have phrased this better, but oh well. Of the population is not 27% or 0.27. And that's it. So it's kind of a long sentence. I know it kind of stinks to have to write so much, but hey, you know, you're being very clear here. We have evidence to the contrary that we don't think it's 27%. We think it's different. And according to ours, it apparently is actually much higher. We could go and do more studies and get more sure and produce more evidence and sort of hone in maybe on a new average we think is more representative of the entire population. But that is how you do that. If you have any questions, let me know, subscribe, and we'll catch you in the next problem.